Good morning, good afternoon. Thank you for joining our first how-to webinar series on data normalization. My name is Al Hilton, the moderator of today's session. Our presenters today will be Bill Grant, Senior Director of Technical Sales and Services in Oz, Vice President of Research and Development. Without further delay, I'd like to introduce Bill Grant, Senior Director, Technical Sales and Services. Bill?
Thank you, Al. Thanks, everybody, for joining. So first, before you get into the details here, I just have a quick disclaimer here. This is definitely an advanced training session. Now, that doesn't mean you need to know anything about normalization. It doesn't mean you need to know everything, but there is some information that you should already know about. We'll try to give some introduction as we go through this, but realize things like when I use the word environment or app def or discovery or collection and things like this, there's some assumption that you're familiar with Evolven enough to understand what those are. So if we cover anything in today's session that is unclear, or if it's a concept that you're not familiar with already, please definitely let us know. We'll definitely do a refresher training with you and get you up to speed, and you'll be able to listen to the recording of this again after that and make good use of it. All right, well, here's today's session. I'll first go through some Evolven terms, some things that you definitely need to know as I refer to them across. It won't be an exhaustive list, but just a few to make sure we know what we're all talking about. Then I'm going to cover what normalization is. I'll talk about what needs to be normalized, a few examples of those. What's the result of doing a normalization? I'll show you what the auto-normalization feature is. And we'll look at how matching is different. And then we'll take a look at that actually in Evolven. I'll cover a little bit about regular expressions. So we'll give you a brief tutorial on regular expressions. And we'll also look at where you can define normalizations as well, so where you'll see those in the product. And then finally, we'll look at how to manage normalization. So when you create these rules, where do they end up? And I'll briefly talk about where the normalization is going in 5.6. We have our VP of R&D who also can tell us a little bit about where things are going. And then, as Al had mentioned, at the end we'll cover Q&A. So if you have any questions, please definitely write those in the questions tab. We'll get to as many as we can. Okay, so first let's cover a few terms that hopefully should be familiar with to you in Evolven. The first one is an environment. Environment is one of these overloaded terms that gets used in a lot of different ways, different products and different contexts in IT. When we talk about environment, we're talking about specifically a technological component or group of components with a configuration and content in Evolven. So an operating system or an application server or an application that's deployed in an app server or a web server, a specific directory, these are all environments. In the examples I'll show, we'll see folders that are represented as environments, and that's going to be relevant when we show these rules. And when we use the word app def, or also known as application definitions, this is the model that specifies how environments are discovered and collected. So think of it as we have essentially a template. The template goes out and says, this is how you would find this thing, and then this is what you should collect. And if you think of a simple folder collector, it's let's say here's where the directory should be. If you find that directory, then go and collect the details. Now this app def also can contain impact and normalization rules, and some of those are shipped out of the box with Evolven. When we create normalization rules, they will not be within these templates, but they'll actually be stored in the Evolven system. So for those of you that maybe have been around for a while, didn't know that, impact and normalization rules actually can be stored directly in the system, and I'll just kind of point that out a little bit so you see it. And then finally, an analysis plan. This is a plan which defines what environments are being compared and how. The how is how did things line up in terms of the comparison. So we'll take a look at that a little bit as well, some of the newer features of how analysis plans look. Okay, so let's get into it. So what is normalization? Normalization is a feature that we use to compare data using the same patterns, but with environment-specific values. So think of the idea here. I've got on the bottom C Windows as a file system, and if you'll notice there's a little N in the configuration tree that signifies that this item has been normalized. And what it says is that this is the etc dir. This is our standard for how we write variables, $, a curly brace, and in etc dir. That indicates that that's the replacement. So now, if we looked to compare the Microsoft Windows 10 environment to another server that also had the operating system, then it really doesn't matter where this etc dir is. If it's somewhere else, then that will get normalized, and we'll treat them as the same. So that's really the intent of normalization, is to make things look the same for the purposes of comparison. So when do we need to do this? Just give a few examples as we go down the line. The first one is random numbers or GUIDs. In some cases, you'll see concepts where there will be some number attached to something. For example, sometimes what a system will do is say, take the first 10 characters and then apply some random number at the end. So if you want those items to align, you'll need to essentially mask out the numbers that will never line up correctly. Could be dynamic names. We'll see an example later, but sometimes you'll see a version number stuck in there. Now, if the version number is intended so that you only compare the 7-zip 9.00 with other 7-zip 9.00 items, then maybe dynamic names are fine. But if you do want those things to align, perhaps you might, for example, do a release where your new release always has the version number in it, but you want to know specifically how those differ. You'll need to normalize out the numbers, and so dynamic names would be a good example of something that needs to be normalized out. Environment-specific names are very common. When I work with clients, I would say this might be even the biggest one that we see, and it comes in a few different forms. It could be within folders themselves, or it could even be within a particular string. So either way, this is the kind of thing that we'd want to normalize out. Now, in some contexts, you want to know they're different, and that's fine. But if, for example, you have a configuration file and one of them is called configuration.dev and the other one's called configuration.prod, if you don't normalize it, you'll simply know that there are two different files, and you have no idea if the settings are different or not. So normalization allows you to treat those as the same for the purposes of understanding those lower level details. And then finally, host-specific directories and parameters. This is one that I just covered in terms of the etc directory, but even the Windows directory as an example would be something that would be unique. And this is just a sampling, but just gives you some idea of when normalization comes into play. So what's the result of doing a normalization? Well, first, before we even talk about a result, let's talk about what would happen if we didn't do normalization. So here we have two servers, host 1 and host 2. On host 1, you have a cwin directory. On host 2, you have a dwindows directory, and this comparison is run. Now, when you run this, what you'll see are only two differences. You'll see that on one system, there exists a folder called cwin, and on the other host, you'll see that there's a folder that is called dwindows. You have no idea if the contents are similar, because they're not the same concept. They're completely different, and so all you see is that there are two differences. And really, that's all. At that point, all you can do is to say that they're different names, and there's no way to know if the contents are different. Now, if we do a normalization, and in this example, we said that this is the win directory. In Evolven, this would be automatically handled for you, but in other contexts, you may need to create a rule to make these things line up. Then when you do this in this case, you would actually see 4 differences. You would see that my file 3 exists on one host and my file 4 exists on the other, and same thing with that my subfile 1 versus my subfile 2. Now, I should say you will see at least 4 differences, because my file 1 and my file 2 are now aligned, there may be details that are being collected of those files that now also will show differences. So the point here is that the count will be different. And I think that's, one thing to keep in mind about normalizations is when you do these normalizations, you will see a different result or a number of differences that come back. It often will be more because the contents within it will begin to align, and there may be some sub-differences, but not necessarily. It may also be that once you align them, suddenly there are no differences, that everything is the same. So the point here is that there will be a difference that's confusing, but a difference in count of the number of differences that you see. Okay, now one feature I'd like to just point out is that some things are able to be auto-normalized. And what that means is that Evolven is trying to determine what things should be normalized and just do that normalization for you. So I can put that into two places. One is the auto-normalization feature, which is trying to figure out what things should be normalized. And in other cases, there simply were, as part of definition creation, as part of the app defs that were created, those also were normalized as part of somebody determining that specifically those things should be normalized. So both of those things apply, but here we're talking about auto-normalization, where the system is trying to figure out which things should be compared. And I'll say that by default, you should simply use the default settings. In other words, this is not something that I typically will recommend that clients change unless they really know what they're doing. So I guess I'll leave it at the point of just being aware that within the server settings, that is where you click your username and you go to the server settings if you're an appropriate permissioned administrator. You'll see that there are auto-normalization settings underneath the server settings. And you'll see the first box is really the main one that you would typically change, is whether this feature is enabled or not enabled. And in the purposes of this session and the purposes of my general guidance is to change that, under the guidance of your Evolven team. We'll tell you when anything needs to specifically be changed, but generally speaking, that feature will do its work for you. And you will see, for example, the results of these normalizations on the configuration page here. I'm looking on the inventory screen. I'm looking at the specific environment, and then you can see normalization parameters that have been identified. Okay, so that's where they live. Okay. Now, one thing I want to separate from normalization, and what I would say is these are separate but related concepts. I think that's an important thing to understand. Normalization, you'll see us apply normalization on specific configuration items. What matching is a very specific alignment that's done in analysis plans. So what I mean by that is that those are rules that are applied only to a specific analysis plan. And its intent is very similar, but it's for environment aligning versus these specific items. So let's take a look at an example here. We've got on the left side, I've got here's 6 environments. We have a folder and then 3 subfolders. And then here we have the same story, another folder and then 3 subfolders. And what we're trying to do is compare this match app prod with match app QA. And when we do that, what we find is that A, B, and C are identified as folders, and X, Y, and Z are not shown, in the sense that A, B, and C as your source are going to show up, and then it won't know on the right side what to align, because by default, X, Y, and Z have nothing to do with A, B, and C, and that would be the normal situation, would be that those are different. But if we were trying to quote-unquote normalize them, we would need to apply matching rules to handle that situation. And I guess I should say you can either handle it with matching rules, or you could manually associate A with X and B with Y and C with Z. So that's an example of matching. I'll cover it as a sample, but realize that this concept is not the same as normalization. Normalization is going to be aligning the specifics. And in terms of environment alignment, that is handled via the matching rules or by manually associating environments with other environments. Okay. So let's take a look at this example. So here again, I'm in the Evolven interface, and I have this these two environments that are here. And if I look at the analysis plans, I've got an analysis plan that I've created with this as the source and this as the target. So we'll go ahead and edit that plan. And I can see here that right now, currently, A, B, and C are here, and there are no subchildren that have been matched. So according to this, we only have a 10% comparison in terms of how these things are aligned. If I actually looked at the results of such a plan, I would see that I've got, 3 differences. It's showing me that A, B, and C exist, and by comparison, I can see that C exists, and on the other side, I have no environment. It's a missing environment. So essentially, think of that as, if you recall, and hopefully you're familiar with this, that within Evolven, the source dictates what is compared. So because of that, X, Y, Z don't really exist to me. All I know is that A, B, and C are not aligning with these X, Y, and Z folders. Now we can handle this, and as I said, we can do this in one of 2 ways, but one of the ways that we could do that would be by simply manually matching. So I could say that this is I'm telling it that A should be matched with X. Now the other thing that I could do is create a matching rule. And so if I click on the matching rule, you'll see all the matching rules that are there. Currently there are none. And I can go ahead and create a rule. So I could say something like, I'll call my rule B or Y, and I'll say it's going to be a pattern. And the way that I can do this we'll talk about this in a little bit, but I'll just create a regular expression that essentially says B or Y, and then I'll just give it a value. And essentially I'm saying that if it's B or if it's Y, then I'm going to replace that with B or Y. That's going to be my particular matching rule. And when I save that and close it, I'll see that the B and the Y now have matched because it figured out that the B is going to be called B or Y and the Y is going to be called B or Y, and now suddenly those 2 things are the same. So you can even see a little indicator here that it applied a matching rule. That's how these 2 things were figured out. So if you look at all these symbols, you can see that the first one was done manual. The second one was done through a rule, and now the last one is a weak match. And essentially what it's saying is that, hey, everything else was figured out, so I'm going to take a guess that C and Z should be aligned. And so that's what's happened. So now if I save that view and run the comparison, now I get some details around actual things that are compared. So as I mentioned, this is not normalization, but it has some of the concepts of normalization. Essentially, remember that even if you do normalization, it's also important that things that are matched within your plan. Okay, so that was a little bit about matching and normalization, and now we'll go through some additional comparisons. Now, one thing I'll point out, in our next example, we're going to do it a little bit different. So if you see here in this version, we have 2 environments. Again, it's the same folder. You have the same folder at the top, prod and QA, but the details are that the actual folders are contained within the environment. So it's a little bit different, and you'll find in different situations that these are done differently. And in a lot of cases where definitions are created by us, we'll use that first and second level comparison, this first and second level breakdown of environments, and that's good for allowing, for example, if I ever wanted to compare A and B, then that would be very useful. But also it's good for allowing us to do some manual association or just scanning lower level environments. But there could be a situation where at a lower level these things are within the configuration. So meaning here I have a tree that has A, B, and C at the lower level within prod, and I have X, Y, and Z at the lower level within my app QA. So let's go take a look at that particular example. So here, what I've got another analysis plan, and this is comparing the prod with the QA. And now in this case, these environments are already aligned as they were before the top level, but there are no lower level ones. So we can just go directly into analyzing the results of the comparison. And when we do that, we can see that we've got now 6 differences. We've got essentially let's sort this by CI. We've got A, B, and C, right? That are, that exist on the source being the prod environment in this case. So the prod is the one that has A, B, and C. And then X, Y, and Z are considered missing, which means that they don't exist on the source. They do exist on the target. If I select it, another way to kind of see this easily is to look on the right side here. So you can see that we've got A, B, and C on the source side. It exists there. It's missing on the other side. And I want to point this out because think about, remember we saw before we only saw the 3 differences. That's because remember that the source dictates what is in context of a plan. We've talked about this a lot in training, but for those of you that haven't done training with us in a while, and that's a little bit confusing, the source dictates the scope of a comparison. So in this case, because the source and target were completely aligned, now all differences are shown. So we see A, B, C, X, Y, and Z. And so what we want to do is start to align these environments. And I'm going to show you how to do that. First, we'll go through a little bit of a primer on regular expressions. It will not be completely extensive, but we'll start covering that, and then and then we can actually go and execute against that. So let's talk about regular expressions. And regular expressions are what I already showed you an example of, but didn't really explain how it works, and we're going to talk a little bit about what these are. Essentially, regular expressions, and these are common. This is a common concept. It's not specific to Evolven. And your development team is probably very familiar with the concept of regular expressions, and you may be too. Regular expressions are essentially these special text strings that describe a search pattern. So think of it as essentially it's saying, I want you to look for this, and if you find it, then do something about it. And in our case, we use it for the purposes of finding when we need to pattern out information. So let's look at a few examples. We talked about the example of random numbers at the end. So in this case, and what we're saying, our regular expression is saying, I want to look specifically for the word myIndex, and then after myIndex, I want to look for, and the square braces are a class, and this class is saying 0-9. So what essentially you can think of this is any digit, and here it says specifically once. So what if I just had myIndex and then square brace 0-9 square brace and not the plus, it would mean myIndex 1, myIndex 5, myIndex 6. Any of those would be valid, but myIndex 12 would not. myIndex 1273 would not. Now the plus sign says take the preceding item 1 or more times. So in this case, what that means is not only does it have to be myIndex 1 will work, myIndex 12 will work, but just myIndex with no numbers will not work. So the plus sign means 1 or more times I expect to see this. If not, it does not qualify. Now, if I wanted to make this optional, instead of using the plus sign, I could use an asterisk, a star. So myIndex and then the 0-9 star would mean that even myIndex would qualify. Now, in our case, we don't, we're expecting that the number is there, so that's why we are explicitly encouraging that. But depending on the context, that may or may not be the right thing to do. Let's look at another example. In this case, we have that 7-zip, 9.00, 9.10, 9.20, etc. So here what we did, and we just did something a little bit different, although it's very similar. This \d part is the same thing as 0-9. So we simply used a different version of 0-9 just to give a different spin on it. But they essentially work out to be the same thing. And also point out that the / is essentially escaping. And so within here, we expect 7-zip, and then we expect this, within this, we expect either a digit or a period. And the plus sign says any number of these. So really 9.00 qualifies. It could be 9.00.143. It could be 9.00 ... It's really very loose in this case. I've used a fairly simplistic version. But the idea here is that we're simply saying that any combination of numbers and periods, one or more of them, qualify. So even 7-zip 9 would qualify, by the way, or 7-zip period would also qualify. We may not want that, but those would also qualify in this this regular expression. And now here's a different, in this case, before I will just point it out, on the previous slides we were looking at square braces, and the square braces essentially allow us to, it will look at each of those terms and pick one, choose one. Here, this is a different kind of a choose. We have a parentheses, and then we've got pipes in between each of our options. So essentially we're saying sales underscore, and then we expect one of dev, QA, or prod in this particular example. One of the options would show up there. Now we could have also done something really crazy. We could have done 7-zip and then parentheses and then 0, pipe 1, pipe 2, pipe 3. So there are options of things that you can put within the parentheses. And parentheses have other meanings in regular expressions. I'll keep it simple for now. But the parentheses are a way for us in this example to basically allow for one of the options to show. So this would be a good format if we were trying to look for either sales underscore dev, sales underscore QA, sales underscore prod. So if we come back to our comparison example, we want to try to get these to be aligning within the comparison, our A and X, our B and Y, our C and Z, maybe a little simplified for what you see in real world, but the concept is the same. If we get these things to be treated the same, then that's essentially the same thing as normalizing anything else. So we'll take a look at that. So again, as we said, when we first ran this is what we saw. We saw that the A, B, and C were not aligned, and so we're going to go and address that in our normalization. Okay, so I'm in the user interface for Evolven, and I have the differences. Now, there are many places that I can actually change rules for normalizations, but perhaps the easiest place to do that would be right within the view here when I actually see the difference. And the place to do that, there's the open knowledge base that I can do. And once you're here, you'll see a few things. First of all, you'll see that the item selected is element A. Now, I need to broaden the scope a little bit on that because I want to make sure that the rule applies not just on A, but on other directories. So instead of just A, I can actually broaden it and say things like all folders, or maybe I could be more specific and pick under a specific directory. In this case, I'll just pick all folders. And now I come to the normalization rules, and this is where I'm going to actually specify the rules. So in this case, it seems somewhat similar to what we saw before. What we're going to do is we're going to define a find rule. So let's say that, again, we're going to say if it's A or X, then we're going to replace that with A or X. So think of it as if I find A, then it's going to be A or X. If I find X, it's going to be A or X. If it's Y, then it's not going to apply this rule. And I'm going to change this to regular expression because that's the type of normalization that I'm doing here. If I had a more specific string, I could do something like, and why don't I show that? I can do something like this. I could say B should be treated as B or Y as a string, and I'll do the same thing for Y. B or Y. And so that's saying that if it's a B, Y, it'll be B or Y. Now what we can also do is test out our normalization rule. So if I put in an A and I test it, then we can see that A was replaced with A or X. I can actually do one per line. It's not very obvious, but we can actually apply multiple tests here, and that's what I've just done. A, B, C, X, Y, Z. And so what I can see here now is each one of those getting applied. So A looks like A or X, B looks like B or Y, C didn't have a match, and then again X and Y are handled but Z is not handled. So if that's the case, then I can add one more item here. We'll do the CZ, C or Z, and then we'll make this one the regular expression 1. Now I'm going to do one more test here, which is I'm going to type in something like the word bike. And when I do that, you'll see that all of my A, B, C, X, Y, Z looked fine. But when I added some other strange item here, notice that it also just replaced B just because B happened to be there. So it's a good idea to use these testers because you can get a little sense for, is it something, did you do something correct? Or maybe you have to improve your logic a little bit. Now, in this case, maybe it wouldn't be a big deal if I know which folders are going to be there, but I'm going to improve my setup here. I'm going to remove this Y. And I'm going to come in here and I'm going to make my rule the following: B, Y, and I'll explain it as soon as I finish it. B or Y, and I've got regex, and I test that, and now B worked, Y worked, but bike did not match. So let me explain what I did there. There are two special characters that I can have in the beginning or the end, which indicates that I expect things to start with this, and then I expect them to end like this. So the caret in the front and the $ at the end is saying that I expect this to be exactly like this. And in such an example here, we're saying it's literally going to be one character because that's the only option that I have here. So the caret and the $ are special concepts in regular expressions. And so that was exactly what we did there. And if we were really doing this proper, we should go back and update all of our rules to incorporate the hat and the $. Looks good. And everything is good. And maybe I'll just add that just in case. Everything looks good. So that is now my rule. So now once I'm satisfied with it, I can save it and then refresh my plan. And as I do that now, suddenly I'll see that I have a difference in the comparison results that I have. And what you can see here in the paths, you start to get a hint that it has actually done an alignment of these environments, which is exactly what we wanted. So that's good. Now we notice one other thing here, which is that it looks like A or X did align, so that's great, but there also were some specific files that are still different. And so very similar situations in prod. I have my connection prod properties file. I have QA properties file on the other side. And so if I see something like that, then I can actually, again, I want to address it so that those files get compared. That's essentially what I'm doing. So let's do that example. So again, I can open up the knowledge base. What I see here is that element connection.prod.properties is the one that's getting addressed here. And obviously I need it to be a little bit broader than that. I'm going to show this example now. Instead of applying, we have to go back and apply the rule, but before I do that, I'm going to just show this example over on the advanced area here. Because what I can do is make changes to this view to accept the rule that I'm about to add. And what I'm going to do actually is I'm going to just edit these. Now, over in this area, it looks for wildcards. So you'll see things like star. It's not a regular expression. It's just simply wildcarding. And so I could do something here where I say that I want the rule to apply anywhere within this named directory here. And then the other change I'm going to make is that I'm going to be looking for connection.star.properties. So what that means is that any time that I have a file that's connection.something.properties, this rule will get applied. And you'll even see that up here that it's sort of updated to indicate that that's what happened. So the advanced screen is kind of nice to give you a little hint about where this rule is getting applied, and you can make some changes to it. And I just made some quick changes to apply this to any connection file within anywhere within this particular path. So let's actually go ahead and add the rule itself. So again, here what we want to look for is we want to look for the condition of dot prod or QA dot. That's what we're going to look for. And I always say that it's best to be as specific as possible. So let's give an example. If I put, let's do it more simply actually. Let's just do prod or QA with our parentheses. Remember, we can choose one. And we're going to replace that with env. And again, we need to remember to change it to regex. And then let's try a couple examples. So we'll try connection.prod.properties, and we'll try connection.qa.properties. And then let's just try production, production, the word production. And we test it. Now what happened was that connection.prod.properties worked great, and connection.qa.properties worked great as well. What we don't like is that the word production also worked. And while this might be fine, we really didn't want that to get caught up in the normalization. So to be just a little bit more specific, what we can just do is say, well, let's add the period before and the period after. And then we'll test it. And then we get exactly what we hope to see. In fact, I'm going to add a period. Let's make it a little bit nicer. Let's replace this with period, env, period. So now we see exactly what we hope to see. Connection.prod.properties, connection.qa.properties. Okay, great. And so now we can save our particular example. We see that it actually got applied, and not only do we see that it got applied, but we can see that it got applied to both of these entries. And now we can refresh the view. And then now we get specific differences around those particular comparisons. I can see specifically where, for example, the username is set separately. I've got passwords that are set separately, etc. Now, once I've got that, I may still accept these as good differences, right? So if I think about this, if I am looking at here I have an example where the main data source is prod and the QA system is pointing to QA. In this example, I'm not going to normalize. Now, I certainly can so that these things look the same, but I don't want to do that because in this case, I'm glad that I know that these are different. And what I would do instead is close out the difference. What I'm basically doing is accepting that this difference is there, and in the context of this plan, I'm okay with that difference. So now, by not normalizing it, now if, for example, the QA one is changed to dev, then I'll see the difference pop up again, and I'll get a hint that that might be something that I need to look into. So that's the difference between why I might normalize versus why I might close something out. Similar here, I've got a different user here. I expected that, so I would simply close that out. Okay. So let's do one more example of a normalization here. So in this example, what we're going to do is take a look at normalizing out version numbers in our installed components. Now, is this something that I'm telling you to go and do, this particular normalization now? Absolutely not. I'm simply using it as an example, but hopefully you'll see, at least as you see it, you'll get some additional ideas of how, how normalization can be done. So let's take a look at this example. So coming back in this case, what we're going to do is we're going to look at the inventory screen. So all the other normalizations we applied were in the analysis tab when we actually saw a difference. In this case, we don't have any comparisons happening right now. We're simply going to look at the configuration itself. So we come over here to installed components, and you can see all the installed components that I have here. So what I want to do is I want to find one of the ones that I want to normalize out. Okay. We'll click on this over all the way on the right side here. You'll see the Edit Knowledge Base button. We're going to click that. And again, you'll notice that it's picking on just specifically this particular element. So if I want it to be a little bit more flexible, I can pick something a little bit more specific. Okay, all nodes directly under installed components. Let's use that one as a pretty good rule. So now again, I switch to the normalization rules. Now, one thing you'll notice on this particular item, I already have a rule. This was a rule that that Evolven creates out of the box, and its intent is to pick out, for example, Microsoft 2008 versus 2003 and things like that. So in this case, it's going to grab the part that's before that and replace it specifically here. You can notice that in this particular rule, it's using $1. So what that means is that it's taking a part of this and replacing it. So we're replacing with $1, what's in between these first parentheses. If you'll recall, I mentioned that parentheses have some specific usages, and one is in this concept called capture groups. And so $1 represents the first parentheses, $2 would be whatever shows up over here, and on and on. So that's one way that capture groups, that's what it's called, can be utilized. But we're going to create a different rule. So what we're looking for is we're going to be looking for, again, that same story. We're going to look for either a digit or a dot, and we want to make sure that there's at least one or more of those, and we're going to replace it with ver, and we're going to do it as a regex. And we can do an example with our writer 3.0. We can test that out. And it looks like that worked. Qt PDF writer ver looks fine. Let's just save it and see what happens. So we save that. The rule gets applied. See that the rule is applied across all these nodes right underneath. And you get the indicator here for the N that tells you what's been normalized. So if I hover over this, I can see it's the version number correctly there. If I hover over here, I see it's applied well there as well. And I see it's applied well there as well. However, up here as I hover, I can see that it normalized the 64 in the 64-bit. And to be honest, I really didn't intend to do that. If I look at this example, I can see that it normalized all over the place. It grabbed the 7, it grabbed the x64, so it was very anxious kind of a normalization. So we want to do a little bit better than that. So let's go ahead and edit the knowledge base. Now, to be honest, there's probably 5 different ways I can improve this particular example, but I'm going to simply do it by basically enforcing that I at least want to see the number and a period first. Absolutely, I don't, I don't want to make those optional. So in other words, I'm going to say something like \d, and again we could say plus, for example, \dot. And so what that's basically saying is one or more numbers, and then a \n and then a dot, and then we'll make everything else optional. So now then we'll say, okay, as long as you get some number and a dot, then we'll take any number of anything else, including not having any. So we'll say that's what our pattern is. This piece 0 to many times, but we must have at least one or more digits and then a period. So we could test that out. We could try something like, okay, let's try x64, and let's try 7-zip, and we could try 3.0 and 2.8.4 and 7.3.0.3499, and we do our test, and we can see here that our x64 didn't match, 7-zip didn't match, but 3.0, 2.84, etc. all matched correctly. So we're pretty happy with that. We'll go ahead and update our rule, and hopefully now we see a much better matching that picked the right things that we cared about. And we could have done other things. We could have said that we only care if it's at the end, right? Remember the $sign that we could use and things like that. So different ways that we could have improved our rules, but here was one example of how we can do that. Okay, well, we covered a lot, so I hope this was helpful, in explaining some examples. It certainly was not exhaustive, and even if it raises awareness on the fact that normalizations may be required when you do comparisons, I think that's an important concept, important for power users, and really, if you took nothing else other than that, that still would be a win to me. But hopefully you were following some of the other things we talked about. Now, here are a few points here. Managing normalizations. Once we created these normalizations, where you'll find them is underneath I'm on the administration screen under knowledge base, and if you pick the specific definition, you'll see, note this little user here and this little N indicating normalization. That's where you're going to see those rules. And so even if you sorted by last modified, for example, you'd very easily see the rules that were just created based on these normalizations. And you have a few buttons, by the way, to revert these rules. If you're selected on a specific one, this first one is the revert this rule button. So what I literally mean is this one I revert back to its original form. This next one is revert all the rules. So remember that I mentioned that there are rules that are supplied as part of the definitions, and then there are rules that are applied on top within the Evolven system. That's what this user indicator is telling you, which rules are within the Evolven database, like the ones we just created. So if you want to revert all those rules, that second button would do it. This one would just revert the rule that we're selected upon. Now, the other thing I'll point out is this. These rules are currently in 5.5, which is the GA version that everybody is on, and before. They are related or tied with the impacts as well. So if you go and change a rule on a particular item, it's also tied in with the impact. So one quick point is that starting in 5.6, these will be created and managed separately. There's going to be more differences than simply that. But the point is that starting in 5.6, you'll see these managed a little bit differently than what we covered today. And along with that, 5.6 will have a number of differences. And I'll just point out kind of a few high-level details. We're still in final development. Al is with us, and if you want to ask any questions of him, I'm sure he'll be happy to answer what he can. But there's still some finalization of it, so I don't have anything here to show. But conceptually, it all works the same as what I covered. In other words, as long as you understand what normalization is, you'll understand how 5.6 works just the same as what I covered here. In fact, obviously, it will be easier to apply. There will be a wizard to assist. Some of the examples that I showed, and probably even smarter ones, will already be part of the solution. So it will give suggestions. It will make it a lot easier to do tests, to create prioritizations. And I'm sure there's even more than just these few. But the point is that normalizations will become a much easier thing to do. So hopefully you're as excited as I am about what our R&D team is doing with normalizations and a lot of these features that make administering and using the product much easier. And with that, I've concluded the prepared material I have for today. I hope this was helpful.
Thank you, everybody, for joining. Have a great day.
Thanks very much.